Up next, we have the Onshape Sneak Peek, hosted by Paul Chastel, our Head of Research and Development. Paul joined Onshape back in 2013, a few months after Onshape was founded. He has spent his entire career in the CAD industry, primarily focusing on geometry, graphics, and user interface. At the beginning, Paul concentrated on modeling features such as sketching and part studios. Now, Paul leads our development team. Joining Paul will be several of his team members who will be showing you what amazing projects they are currently working on. As you will hear from Paul, we don't do this often. In fact, we have never given a public preview of upcoming features. However, for this special occasion, we are making a rare exception to our own rule. The only promise that we will make is that these will be released when they meet the quality standards that you've come to expect from Onshape. And with that, let me turn this over to Paul. Paul, take it away.
Thanks, David. Hello, everybody, and welcome to the Onshape Live Sneak Peek. My name is Paul Chastel, and I lead the team at Onshape that develops, deploys, and operates the Onshape product. I'm really excited to be able to share with you today some of the things that my team are working on. Now, I can't make any promises as to when you will see it, because with an agile development process, we put out stuff every 3 weeks. Some things you see will come out in the next month or so, others towards the end of the year. But we are working very hard on all of these things, and I think you'll be very happy with what you see. Now, when I say we're going to show you what these functionalities are, that's exactly what I mean. I'm not going to show anything. We have this lovely bit of culture at Onshape. Every week on a Thursday, we have a team meeting. The whole team gets together, and there's always a few demos that my team stand up, show what they're working on. And so we thought, why not just bring that to all of you? So not only will you get to see some of the functionality that we're working on today, but you actually get to see the people that are building it. And so with that, I'd like to hand it over to one of our very first engineers, Lana Saxonoff, as she introduces what she's working on right now. Over to you, Lana.
Thank you, Paul. Hello, I'm Lana Saxonov, working for Architecture and Feature Script Group. Today I am presenting weldments functionality. Approach to weldments is an example of how feature script benefits Onshape users. Over 3 years ago, Neil Cook wrote feature script beams, which helped a lot of our users to create beams geometry. Neil also did a great job of staying on top of feature script improvements and incorporating them into the beams feature. The latest version supports use of custom profiles and generates cut list. Feedback from users of this custom feature informed design of the functionality currently under development. Elif Tosun, one of the top geometry experts in our company, written a robust frame feature with flexible geometry selections, improved profile attachment control, and joint options, which can be specified per individual joint. We have rethought the workflow and decided to separate building frame geometry and generating cut list. This allows for more flexible geometry tooling, and cut list combining geometry generated with different profiles, imported geometry, or geometry created by features other than frame. Recently released composite part and custom table functionalities are used to group frames and generate customizable cut list. Frame feature has options for trimming geometry as it is being created. Not only curves and faces, but also vertices can be selected to define a frame. When mirrored or patterned, frame geometry retains its properties and is included in the cut list. In more complex configurations, frame trim feature can be used to trim geometry in desired way regardless of the order in which the frames were built. There is still some amount of work left to provide access to standard profile library and make it conveniently extendable by the users. Another goal is a tight integration with drawings. We will support adding cut list table to drawings of frames. I would like to appeal to all the weldments users to help us deliver weldments functionality which best serves your needs. Please use feature script beams and give us your feedback. If you can share examples of frames you typically build, that would help to validate our functionality and the workflow. When we are close to being ready to release, we will ask for user help with UX testing. Please volunteer. It helps us to improve the product. Thank you. Back to you, Paul.
Thanks, Lana. I'm sure there are a lot of people watching and they are very happy to see the focus that we're putting onto weldments. And if you're one of those people and you'd like to get hold of the custom feature or see how you can get your feedback to the team, we'll be posting some instructions on the Onshape Live website in the sneak peek section in the next few days. Now, I'm not just going to talk to you about mechanical design today. We've got some other things we want to share with you. And to do that, I'm going to hand it over to Rob Lacey. Rob, it's all yours.
Thanks, Paul. I'm Rob Lacey, Technical VP here at Onshape, responsible for ECAD-MCAD integration. I'm going to show you a quick demo of how Onshape users can now collaborate with electrical PCB designers using our new ECAD-MCAD connector. So here we're designing a handheld GPS unit in Onshape that will need to include a printed circuit board. The shape of the board will be determined by the shape of the case that it needs to fit into. The design of the case has already been created, so we're creating a part in context such that the shape of the PCB follows the shape of the case. By projecting the edges of the case part, we can create a sketch to represent the shape of the board and then extrude it to the required thickness. With our board part complete, the next step is to add our ECAD-MCAD connector tab into the Onshape document and import the part into the ECAD-MCAD environment. Now that the board has been imported, we can see from the 3D preview that the shape is correct, so we'll export it to a format that the PCB tool will understand, IDF. The electrical engineer can import the IDF data into their ECAD system and use it as the basis of their design, placing components and adding the routing. Once the ECAD design work is complete, we'll want to verify the form and fit of their updated design. So the IDF files generated by the ECAD system can now be re-imported back into Onshape. You can see from the preview that the electrical engineer has added components to the board. Some of these components have simple shapes like this connector highlighted, while some are more detailed. The simple shape components were automatically created from the shapes defined in the ECAD system, whilst the detailed components, such as this IC, have been created previously and added to the tool's inbuilt component libraries. The ECAD-MCAD connector uses rules called mappings to determine which Onshape models are used to represent a component and how they should be orientated. Mappings can be configured to reference simple models created from the ECAD data, detailed Onshape component models, or any combination of the two. Here, we're updating a mapping to tell the tool to use a detailed Onshape component model for this connector. Returning to the preview, you can see it's updated to show the detailed connector model. At this stage, this is still only a preview, however. It doesn't exist as an Onshape assembly yet. So the next step is to build the board and components in Onshape. Onshape will automatically create new models for any new components that have been defined in the ECAD data. With our Onshape assembly created, we can see there are a couple of problems, and some components, such as these connectors and the USB holder, will need to move. These changes can be made by using tools we're already familiar with in Onshape by simply dragging and rotating the components to their new positions. Once the change is complete, it's time to send them back to the electrical engineer so they can review and update the design in their ECAD system. As before, all that's required is to switch to the ECAD-MCAD tab and import the updated design. With the updated design re-imported back into the ECAD-MCAD connector, all we need to do is save the design back out as IDF for the electrical engineer to update the routing in the ECAD system. And that's it. With ever more products now incorporating electronics, hopefully a lot of users are going to find this new functionality really useful. And with that, I'll hand you back to Paul. Thank you.
Excellent. Thanks for that, Rob. Now, engineering isn't just about design. It's not just about changing the shape of things or putting them in different places. You need to know whether that design meets requirements. And to show you how Onshape's going to be helping with that, I'm going to hand it over to Evan Novak. Evan, all yours.
Thank you, Paul. My name is Evan Novak, and I'm Director of Graphics at Onshape. I'm excited to share a bit about the work we've been doing to bring simulation capabilities into Onshape. With simulation on Onshape, we will enable quick feedback about how your design performs directly in the modeling environment, right at the moment of inspiration. This will enable informed iterative feedback during your design phase. Let's take a look. Here we have a bicycle brake caliper designed in Onshape. The keen observer will notice a few new pieces of UI here. The toolbar above has a few new icons. This will allow you to place loads in the context of the assembly. In this case, we're pulling on the assembly in the direction of the brake cabling. We've also fixed a couple of assembly components relative to ground. And that's all you need to set up a simulation on Onshape. The system will automatically apply relationships from Onshape's mates. There's no need to redefine them specifically for the simulation. That can save a lot of time when simulating a complex mechanism. Once the simulation is defined, we can open up the simulation panel on the right. From here, we can kick off a simulation. It's worth noting here that the UI will be expanded over time as more simulation features are developed. The work to actually perform the simulation is done in the cloud. Once the results are ready, they're pushed to the browser, and by default, we'll see a stress plot. We can change the color mapping to suit our liking. We can also visualize displacement due to forces in the assembly and animate that displacement. Since we are viewing a simulation natively in Onshape, you can expect other native Onshape features to work directly alongside it, like exploded views. As a first-class component of Onshape, you can expect the same ease of use and interactivity you would find in other pieces of the software. For instance, if you make changes to a reference part in a workspace, the assembly will update, and you can see the downstream effects this will have on simulated properties. Here I have two windows open showing a tuning fork I'm designing. On the left is a part studio where the parts are defined. On the right is assembly where they are constrained together. I already have a modal simulation that's running to calculate the tuning fork's natural frequencies. Now I can edit this variable to change the length of the fork. Since this is Onshape, the edit could have just as easily come from a colleague who's working halfway across the world. But I'm flying solo today. Committing this change will update the part studio, the assembly, and the running simulation. In a moment, we'll see the effect this has had on the simulated property. And as expected, decreasing the length of the fork increases its frequency. In this way, you can quickly iterate on your design and bring simulation feedback into your workflow. So that's my preview of work going on with simulation at Onshape. We are working to provide simulation capabilities that are easy to use and provide real-world utility for iterative feedback during design. We are not targeting post-design validation at this time. We have great partner apps that will continue to provide facilities for that. When you do use simulation with Onshape, you can expect it to have the same benefits as other areas of the application. It will be accessible from anywhere, have built-in data management, and will be very collaborative. Thank you.
Thanks, Evan. Now, you won't be surprised to hear that a lot of people internally are wowed whenever they see that demonstration, not just the graphics, but how easy it is to fit simulation in with a design workflow. So we've got design, we've got simulation. Once you've got your assemblies, you've got a whole bunch of properties that you want to be able to communicate or record. And I'm going to hand it over to Dan, who's going to take you through what I'm sure will be some very popular improvements to what we have today. Dan, it's all yours.
Hi, I'm Dan Jacobs. I'm in the Feature Script group at Onshape, and I'm very excited to show you a preview of our new computed properties functionality. Custom computed properties give you the full power of Feature Script to compute properties for the parts in your designs. They're computed automatically based on your part's geometry and their other properties, and they appear in property lists, bills of materials, etc. Let's dive right into an example. Just like custom features, you define computed property functions in a Feature Studio. Here are some examples. As you can see, some simple computed properties can be defined directly in terms of built-in operations. That works for things like volume and surface area. Computing the mass of a part also requires access to the material property because we need the density as well as the volume. And then, computing a shipping size based on the bounding box of a part is also pretty easy. Next, we save the Feature Studio, create a document version, and then we can define the custom computed properties. Now this is very similar to creating a normal custom property. We provide a name, type, category, and then for a computed property, we also specify the Feature Studio version and function name. This isn't the final user interface. We'll be using the selection dialog for choosing the Feature Studio version and property function. I'm going to use this simple 10 centimeter cube as a first example in order to focus just on computed properties. When we ask for the cube's properties now, our new computed properties are included in the list. Note that the values are exactly what we'd expect, and the units for the values are there too. We can also see our computed properties in the bill of materials. We go to our assembly, open the BOM, add our computed properties to the BOM table, and there they are, just like that. And the same goes for drawings when you insert the table into the drawing. Now if we go back to the Feature Studio and modify the part, the computed properties are automatically updated there and everywhere else, just as you'd expect. Now, here's a more interesting example. When we show the bill of materials for this assembly, all the computed properties are there, providing as much computed information as you need. There's no end to what you can do with this feature. We're very excited about it, and we think you're going to love it. Now, back to you, Paul.
Very nice, Dan. Very nice indeed. There's a lot of people that have been asking for this this piece of functionality, the ability to have these properties that get calculated and stuck into the bill of materials. Of course, they may be shouting at their monitor right now, saying, "Hey, where are my drawings?" Well, rest assured, Dan is on the cutting edge. He doesn't have any drawings in his build, but by the time we deploy this, drawings will be part and parcel of what we have. You'll be able to take all those computed properties and put them all the way through to drawings. And speaking of drawings, we know how tricky it can be when there's something that you can't do, because maybe the workaround is very time consuming, or maybe it's just not possible to work around. And so I think a lot of people are also going to be very happy with what Hailong is about to show us. So let's not waste any more time. Hailong, show them what you got.
Thank you, Paul. Hello everyone, my name is Hailong Li. I'm the director of Onshape Drawings team. In drawings, hatches represent materials for different parts. A highly requested feature is to control cross-hatching to distinguish parts and materials. With our upcoming drawing updates, you can now modify cross-hatching on section views. You can change hatches of particular instances in one section view. Here, we just remove the hatches from the instances in the section view. You can also apply changes to the same instances in all section views. Here, we are making a change to 2 instances in the section view, then applying the change to the same instances in all section views. There are various settings you can change for the cross hatches. You can change the hatch pattern, pattern density, angle, color, and what the references these settings apply to. Finally, there are drawing property settings that allow you to change all custom hatches across the entire drawings. In the near future, we will be able to add cross hatches to faces and to relate the materials to specific hatch patterns. And we'll be adding more hatch patterns. Back to you, Paul.
Thanks, Hailong. I'm sure a lot of you that watched Hailong there are wondering when you're going to get hold of the crosshatch. And maybe a lot of you are looking at it thinking, it looks like it's ready. Well, it almost is. And so this is one of the ones that I would hope we would get deployed to you sooner rather than later. No promises, but I'm really quite confident we'll have that for you soon. Now, a little over a year ago, we were acquired by PTC. And PTC has a lot of engineers with a lot of different skills and expertise. And we've been lucky over the last few months to be joined by some of the Windchill team who have been helping to build out some of our functionality. So I'm going to hand it over to Nate from the Windchill team, who will talk to you about what they've been up to.
Hi, I'm Nate Kroll, a developer from the Windchill PLM team working with the Onshape team to create a new change management process for Onshape. As you can see, there is a new change management navigation called Changes. From the change management page, you are able to view change requests and change orders. You can search or use the filter criteria. Select the Create menu to add new change requests or change orders. Let's look at the change request, Improve the durability of seat post design, which is currently in the in-analysis state. In the change request details page, there are several properties which help to define the requested change. A seat part has been added as an affected item. The need date is currently not set, so let's set a date. Notice that the participants have already been specified. The approver is currently not set and is optional. For this change request, we are going to complete the Analyze Change Request and directly approve it. A change order was automatically created for the change request. On the change order details page, you can see that the matching change request properties were automatically set on the change order. The seat part was also added as an affected item. We need to assign a change owner to define the change order. Notice that a new action item called Define Change Order is now assigned to the change owner. The change owner reviews and defines the change order. For this change order, we are going to just set the auditor and the change task assignee. We can now complete the Define Change Order action item by selecting Implement. Notice that the change order and task are both now in the In Progress state. The change assignee can view their assignments from the action items. The assignee can review the change task and make the appropriate updates to the affected items. The change task can be optionally routed for review. To skip the review, select Complete. Notice that the change task state is now complete and the version column was automatically set to the next version. Navigate to the change order and note that the state is ready for release. There is a new Audit Change Order action item which is assigned to the auditor. The auditor can review the change order to ensure that all change tasks are completed. When the change order is released, the state will be updated to the final release state. The release change order can be viewed from the affected item part document. Back to you, Paul.
Thanks, Nate. There's some really excellent improvements there that should help with collaboration and with working together on changing requirements. And it's been great working with you and the team over the last few months. So thanks for that. Right at the very start, I talked about Lana and how she was one of our earliest engineers. And now I want to introduce you to one of our most recent engineers who joined the team just a couple of weeks ago, along with his colleagues out in Australia. So joining us all the way from Australia, I want to hand it over to Paul Arden. Paul, all yours.
Thank you, Paul. I'm Paul Arden, the former CEO of MyGenius and Software Development VP in the Onshape team at PTC. If you haven't seen our existing Reality Server application for Onshape, it's a photorealistic rendering tool that runs inside an Onshape tab. It runs entirely in the cloud using GPU-accelerated servers, so even if you have a low-end device or machine, you can still get great renderings. There's an extensive library of pre-made materials and lighting environments, and it lets you very quickly and easily create realistic renderings without leaving Onshape. Since the acquisition, we've been working hard to add new features and integrate it even more deeply into Onshape. So let's have a look at rendering in Onshape today and some cool new features of what's coming. This is just a document that I've been working on and setting up some rendering in. So let's switch to the rendering tab and finish some refinement work that I've already been working on. It looks pretty good already, but I think we can make it look a lot better. I mean, the environment in particular is the lighting is looking quite blue. So let's look for an alternative environment in our environments tab here. Let's search for something, maybe a machine shop or something like that. If we say shop, there's a nice machine shop environment there. Let's drag that on and have a look. That's already looking much better. Now this plastic tube here isn't quite right, so let's change the color of that. Let's search our material library for a transparent plastic. We'll use this clear one here. We don't need a color on that. It looks better. And the metal needs a bit of work though. If we click the metal, you can see that it's one of our new V-Materials 2 materials with these nice parametric parameters for scratches and reflection, variation, that sort of thing. But the scale looks a bit big on those scratches, so let's make them 1/4 of the size. And let's increase the variation in the reflections just to give the material a more aged look. And to get a bit of imperfection in there, we'll up the variation on the scratches, and you'll see now we can get a nice bit of imperfection showing. But there's still a little problem there with the edges of the objects. They look very harsh, that very hard edge. So we have a new feature here that's enable round corners. If we turn that on, you'll see that all the edges get very slightly rounded off, and that just breaks the edges and gives you that nice highlight. Now I think it'll look better in context, so let's get rid of the background so we can see that environment that we're using to light it up. And we can see the background there, but it doesn't really look all that photographic yet. So what we can do to fix that is add some depth of field using this new feature we're adding. This lets us just pick the focus distance, which thing we want to focus on. We'll pick the object there, and then we'll see the background go nicely out of focus. This is an f5.6 aperture. We can also control the number of aperture blades, which controls the look of the bokeh in the background. You can see here if we switch it to 5, and you get this pentagon-shaped highlights. We'll up it to 9. That usually is a nicer camera, nicer lens. It gives a better result. That's looking quite good now, so I think we can stop that and we can save the rendering back into Onshape and put it in Onshape. And there's our rendering sitting in an Onshape tab. And that's a quick demo of rendering. Thank you. Back to you, Paul.
That's awesome, Paul. I love Reality Server, and it's great to have you on the team. And I love the way that you're getting up to speed so quickly too. I'm sure a lot of people watching here, you're looking at this going, "Oh, we really want to get this in Onshape," and we'll get it to you, but it may take us a little bit of time. Speaking of which, I'm not making any promises about anything that we've shown. As I say, we'll get things to you when they're ready. But that is it. That's everything I was going to show. So thank you to my team. Design, simulation, detailing, collaboration, all of those areas all come in this year with a whole bunch of other stuff. This isn't everything we're doing. There's a whole bunch of other things that we're working on as well. So we've got a lot to share with you in the coming year. So now I would like to get the team back together so that they can answer any questions that you may have. So I'm going to ask them all to join us here now. And I'm going to go and I'm going to check in with Brad and see what questions we got in the chat. So bear with me and I'll be back very shortly. Thank you. Okay, we're back and we have the whole team here. I'm also joined by Bradley Sawn, who is going to help us through, well, what looks like a mountain of questions.
Hey there.
So the first one here is for you, Lana. What other entities can be referenced for frame generation besides sketches?
It doesn't have to be a sketch curve. You can select any edge. You can select any face and its edges will be used. You can select separate vertices and we'll connect them by polygonal paths. So it is very flexible. You don't really need to create 3D curves in order to use it.
Excellent. And Paul, I have a question from you about the team and how we work internally. Does the team use Git for version control?
Oh, is that an internal question? It sounds like maybe asking whether we use it for our own version control. So the version control within Onshape is something we wrote ourselves entirely, inspired by Git. We do use Git as a development tool, but we don't use Git within the Onshape product. I hope I answered the question.
Absolutely. And a question came in for Lana as well. Can you modify weldment profiles or add custom profiles like Neil's custom feature?
You can use any sketch from any part studio. You can just select a sketch and use it as a profile. We are working to make it easy for users to create their own profile libraries or libraries for their companies, which will be accessible similarly to standard content libraries.
Thank you, Lana. Some ECAD questions. What ECAD formats are supported, Rob?
On the way in for import, we currently support IDF2, IDF3, IDX version 3 onwards, and Eagle version 6 on the way in. For export, so back out to ECAD, currently we're only supporting IDF 2 and 3 at the moment, but we're going to be adding a whole load more going forward, including a full bidirectional IDX flow.
Very nice. And in that demo, was that an automated keep out that we saw?
It does support keep outs. It wasn't created automatically, but you can model keep out areas, both 2D and 3D, within Onshape, and then you can export that back to ECAD, and ECAD will recognize that as a keep out or keep in area. And conversely, if somebody in ECAD defines a keep in or keep out area, we'll model it as a 2D or 3D area within Onshape. So you can fully bidirectionally define keep in and keep out areas.
Another question here, Rob, about ECAD. Can you add new ECAD components to the board in Onshape before you send it back to the ECAD system?
Yes, you can, although it's kinder to do it within the ECAD system first rather than adding new components in Onshape. But you can model a completely new component like a connector or something in Onshape and then export it back out, and it would end up in the ECAD system. The ECAD system might not recognize its part number and footprint. So the kindest thing to do to your ECAD guy is to let the ECAD guy model the connector first so his ECAD system knows about it. But yes, it's fully bidirectional in terms of components as well as keep-ins and keep-outs.
And this next one's for Paul Chastel. We're seeing a lot of new modules with simulation rendering here. So are these going to be included with an Onshape subscription? Have we thought about that kind of thing yet?
We have. We're pretty sure at this point that we're not going to have different modules that have to be added to Onshape that it would be part of an existing plan. Exactly which plan we put functionalities in, we're not sure of yet, but we're not going to complicate things with different products and so on. A lot of the existing customers that are watching this will get the functionalities as soon as they get released.
Gotcha. And we got another question here for Evan. For the FEA, is this run across a large number of cores so that it's super fast?
Yep. So FEA is something that's very parallelizable. So we can spin up a faster machine in the cloud that has more cores, and we'll be able to take advantage of that. Or we can even throw a GPU at it to make it go very fast. And that's the great thing about it being in the cloud. You could be on a Chromebook, fairly low-powered machine, but you could still be looking at your simulation results there. Or we could throw multiple machines at it. So if you've got multiple simulations you want to run in parallel, you can do that as well. So, yep.
And while we're on the technology, Evan, what is driving this simulation? Is it ANSYS Discovery Live?
No, not ANSYS Discovery Live. We're not planning on talking in depth about the tech behind it, but suffice it to say, we've got something that's very efficient, accurate, and is going to scale well in the cloud. So.
And a question came in for Rob here. When you move the component on the board in ECAD, does it update the traces on the board CAD and reroute after it's moved, or is that more of a visualization? So if it's more of a visualization, what happens after we move it? How does that ECAD engineer work with it?
If I think I understand the question, with the IDF, we're not bringing the traces or the routing into Onshape, but if you move a component and then you export it back out from Onshape using the IDF format, then the ECAD system will know that the component's moved, and then depending on the settings in the ECAD system, it will recalculate the routing and traces automatically. So that's down to the ECAD system. But yes, IDF as a format's been around for kind of 20 odd years. So all the major ECAD systems, Mentor, Cadence, are used to taking IDF data in, and they will recalculate their traces when the components are moved.
Okay, right. Let's move on to some questions for Dan that are coming on the computed properties. How do people learn more about using FeatureScript? Because you were showing FeatureScript there as a way of doing this, Dan. How do people find out more about that?
Sure. FeatureScript is one of the foundation technologies inside of Onshape. The best ways to learn about it are from the Learning Center online and from the forums, and from playing with it. I highly recommend, open up a Feature Studio, try some things out. When you have questions, go to the forum. It's pretty easy.
It is actually some of the only coding I do today, Dan, is in FeatureScript. Now, will the properties creation be something that only admins can do, or?
Well, the computed properties sit on top of custom properties, and not all the different type of licenses have access to custom properties. So you need that in order to define new computed properties. We will probably have some standard Onshape computed properties, and those will be available to everybody, but that hasn't been decided yet.
And Dan, they just keep on coming in for you. I know computer properties is a hot topic with a lot of interest. Right now, do we see those being able to be summed over assemblies, like creating the crate size?
Excellent question. We're currently working on defining assembly level aggregate properties that are based on the computed part properties. That's going to be coming. It may be released separately because it's a new feature, but we're definitely working on that now.
And do you have any ideas or thoughts on how this might integrate with talent tools for like supply chain management or anything like that?
The metadata, the whole metadata system within Onshape is all of one kind. So whatever kind of properties you have, whether they're manually edited properties or computed properties, will all work together. So any place where you see properties, you'll see all of the properties.
Okay. Well, thank you, Dan. We have some questions here for you, Hailong. First one is, can cross-hatching options be specified in a company drawing template?
Yes, you can. You can save default pattern into your company's template. Then you use this template to for your drawings. Yes.
Okay. Thank you. And will the cross-hatching be seen in detail views?
Yes. All the custom cross hatchings, there's no difference between those custom hatchings and the system default hatchings. That you should be able to see all the custom cross hatching in detail view with no problem. Yeah.
Thank you.
And we got go ahead, Paul.
No, Brad, carry on.
We got a few questions coming in, it looks like, for Nathan on the change management. Is the changes functionality only available on the enterprise accounts, or where will we see this in Onshape?
We started with the enterprise accounts for change management, but we are looking at the possibility of supporting it for other types of accounts.
And we see a lot of great project management tools getting started to be built into Onshape. I mean, naturally with our version and history, and even the task assignment and comments. Can we expect any more tools for like Feature Studios, custom features beyond just version control, you think? Or how do you see that getting tied in?
Right now, I guess it's not something we've thought about. So we'll have to take that question and think about it a little more.
Absolutely.
Okay. Thanks, Nate. Some questions on rendering. So for you, Paul, will you be able to bring in your own texture mappings?
Yes, that's straightforward. You can do that already. You can upload textures either to use in your materials, and you can also upload HDRI environments for the lighting if you want to use a different lighting that we don't have in the library.
And I wasn't quite sure in the context of this question, Paul, but I'm curious to see how you interpret it. Will the rendering software be fully built into Onshape?
Yeah, I guess the argument is it's already fully built in as an app because it's an integrated app and works very well internally. However, we definitely anticipate a tighter integration than we have today. So there's things that we'll be able to do now that we haven't been able to do in the past as a pure application. So we're definitely anticipating some of that.
Actually, this one isn't about rendering, but I like this one. Could Evan, to you, could the tuning fork play a sound with the correct frequency once solved?
Well, I haven't thought about that. It certainly could. I don't know if it's going to make it for the first release, but you know, we're an agile company. If we put simulation out there and find there's a groundswell of demand for it, we can work it in, I think.
Thank you. Back to you, Paul. Composite parts. Can you do composite parts with the rendering?
They should work already, actually. So if they don't, they can submit a support ticket for that. But composite parts are supported.
Excellent. And how about things like section view? We saw that simulation will work with exploded views. Can you use section view with rendering or perspective view?
Yeah, we export a default section which you can move around, but what a lot of people seem to not know exists in Onshape is named views. So in Onshape, you have this feature called named views. And if you set up perspective views or views with section planes as named views, they get converted into Reality Server. So you can then go to them once you've gone into Reality Server. So that's the best way to set up your section planes, is to do it in Onshape and let them convert.
Excellent. And another question here for you, Paul. Is the rendering setup associative so that it can be set up ahead of time?
Yeah, so I think that maybe relates to whether it's sort of connected into the Onshape data directly or not. So right now it's more of a translate and render process. What we do have is we keep all the identifiers for the faces and everything. So you can reconvert and keep your materials later on. So there is the ability to update from Onshape. What we don't have is a sort of live direct associativity at the moment, but we do have that partial.
Okay.
And
Cool.
Nathan, one came in for you. I don't know if we're able to answer this or not, but what's the backend engine that we have for managing our change management?
So we're using the workflows that you use with release candidates today. So those are driving the entire state changes for change management.
And then as far as releasing goes, we're also at the end of the day, we're reusing the release candidate to release your parts and assemblies. So it's all tied together with the existing functionality that's there. It's just you have a more state-driven, task-managed solution than what's there today.
Okay, so Paul, question for you. Are we going to see some Learning Center content for rendering?
I'd say almost certainly yes. I'm not directly responsible for that, but that's got to be a certainty. If you click the YouTube button in the application, though, it'll go to the older channel for MyGenius, which does have about 20 or 30 tutorial videos you can look at in the meantime until we get that up and running.
Okay, thank you, Paul. We're out of time, I'm afraid. We're going to have to wrap it up now and get on with the rest of the show. And my team here are going to go off and get working on the functionality here so we can get it out to you as soon as we can. I'd like to say thank you to all of the team for joining us today and for showing what they've been working on. And David, back to you.
Wow. Thank you, Paul and team. I have to say, I never get tired of seeing the amazing things our team is building. As Paul mentioned, we actually meet every week as a full team to share what's been going on with the business, but also really to see what our technical team is working on. As you may expect, it never gets old.